For the last example on chapter 5 in loops, we are going to take an example of the random walk, and which is also represented graphically. So for the random walk, I'm going to give you first a run of the program in order for you to see what it does exactly, and then we are going to analyze it step by step. So here what we have is that we are drawing actually an array like this, okay, like a table, or like a, consider it like a chessboard. So we have several horizontal lines at first that we start with our cursor. It's actually 10, if I'm not mistaken. We're going to look at the code once more. And we're going to do the same but vertically. Okay, more vertical lines that we have. So this is the lattice that we have. It's actually a 16 by 16 lattice. Okay, 16 by 16 lattice. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 16 lattice. Okay, and here we have specified the dimensions of that lattice. And once this lattice has been drawn, we go back to the center and we start doing a random walk. So here the cursor at each time will choose randomly where to go. So each time we run the program, the path is actually going to be different. This is a random walk, and we are going to keep walking until we get out of the grid that we have. So the time it will take really depends on the random values that the cursor is going to take. In one time, it could be straightforward. In another time, it could take longer time. So let us just see at what time our cursor is actually going to leave the grid. So you see, like we were at the extremity, we got back in the middle. So it could take like a while because we are allowed to go back through the same path. If we wanted a program that does not allow us to go through the same path, we would have needed to mention it differently. But here we got out of the path, and once we leave here the lattice, then the program stops. So let us see how all of this program was done. First of all, we of course need to import the turtle module and need to import the random int from the random module. So the turtle speed, we have set it to the slowest in order for us to see exactly what is happening. We could have increased the turtle speed for things to be much faster, but we really want to see the walk. We want to appreciate the walk that is done by the turtle. And here we draw a 16 by 16 lattice, and we choose the color to be gray for this lattice. We start with x equal minus 80, and for y in range of minus 80 until 80 plus 1 with an increment of 10, we each time take the pen up, we go to xy to draw a horizontal line, okay, the value xy, we put the pen down and we go forward. So that's how we draw the horizontal lines. We do the same for the vertical lines. Then once this is done, we choose a pen size of 3, a color red. We put the pen up in order not to draw anything on our passage before going to the center 0, 0. Once we go through the center that we have right here, we put the pen down, x equal y equal 0, that the current pen location at the center. And while absolute value of x is less than 80 and absolute value of y is less than 80, we are gonna continue the random walk. So we start with a random walk, a random integer that goes from 0 to 3. And here, the random integer that goes from 0 to 3 is going to decide the angle. Okay, 0 for a heading of 0, 1 for a heading of 270, 2 for a heading of 180, and 3 for a heading of 90 degrees. And each time we either go plus 10 right here for the walk right. Here we're going to go for a walk down, so we need to go down. Here we go for a walk left, and here we go for a walk up. So the 4 directions that we currently can have. And in the end, turtle done in order to keep the loop and see everything that is going on. So just to do a small recap, we first need to draw the lattice right here. Then we need to assign to the pen size a color and a diameter in order to see the walk of the line over the lattice. And we go to the center, and here is the conditional that we have in a while loop with if, elif, elif, elif. So this is the loop. These are the conditionals, where as long as we are within the lattice, as long as we are still within the lattice, what we do in that case So we did the absolute values in order not to have to mention minus 80 and plus 80 twice. So we just do an absolute value of x. So if I have minus 85, so if I am all the way to the left, then the absolute value 85 is less than 80, and I have thus left the lattice. So as long as these two are satisfied together, so as long as I'm still in the lattice in the horizontal and vertical conditions, then I can continue doing my random walk. But as long as one of these is broken, if only one of these is broken, then the whole loop stops and my random walk is over. So that's the idea of a random walk. Is something completely random. And as long as you run the program, each time it will give you a different output. It's completely random. And that's the inner beauty of it. So I hope you enjoyed examples on chapter number 5. And I'll see you next in chapter number 6.